relative minima mean?
Relative minima is referring to, it's another way of describing local minimum.
Okay.
All right, minima is just the plural for minimum, right? So if I refer to relative extrema, extreme values are like max and mins.
Okay.
Or local mins and maxes. I say it so many different ways, but that's what I would be referring to. So let's see. So we are reviewing, I guess, graphing polynomials right now. And then, well, polynomial functions anyway. It's a terrible M. Polynomial functions. And then since we have the quiz today, I'll also open up the floor to any other questions we have. So I think you guys had some questions on, was it?
I did not.
Am I on the right page?
Yeah.
Apparently I screwed up. Thinking I was in. Yeah.
Let's see. So let's take a look at this and
I literally had
Are there questions like this on the quiz?
yeah, the idea, like multiple choice, where you'd have to kind of analyze the information in a graph. So let's see. Let's see, that's not quite. There we go, now it's good. I'm going to just draw maybe a picture for each of these. I think I can fit them all. I think I can fit 4 here. Just general shape graphs that we'll be able to analyze. So let's see, third degree polynomial with a positive leading coefficient, and the question is, what is the relative minima that are possible for each condition? So a third degree with a positive leading coefficient, we know the end behavior, that the cactus is going to be like that, kind of negative, negative, positive, positive matching up. So if I want to figure out the relative minima, it looks like there would be at most one local minimum point, right? Technically this goes down infinitely, but infinity, negative infinity is not a minimum value, all right, since negative infinity is not technically a number. But it does have that one valley there, right? So that's why the answer is 1. Let's see, third degree polynomial with a negative leading coefficient would be this little swoopty guy. When my son Griffin was born, I described his legs as being like swoopty feet, where like he just had like no ankles. It was just like whoosh, and like his legs were still like bent back from living inside of a sphere on the inside. Like his legs were just like whoosh, just arced along the wall. It's kind of cute. I don't know. They're not swoopty anymore, but I like to think of this curve as a swoop. S-C-H-W-O-O-P is how I'd spell that if I had to. I don't know if it's a word. It sounds good to me. So once again, one local min would be present at most. Let's see, a fourth degree polynomial with a positive. That's our classic W, right? So that one would have 2 local mins at most. And then lastly, a negative leading coefficient, 4th degree, was the M situation. And the number of minimum, or local mins, right, would be 1. And then if I wanted to consider maxima, there's 1, there's 1, there's 1, there's 2. Right?
So it's basically the lowest point of the
Right, yep. So I mean, and if I had like, I mean, you could have like multiple minimum, you know, depending on the graph. So, other questions that I could help you guys with? Did we have problem 2 assigned? I think so, right? Yeah. Why did we not choose one of the negative zeros for the volume of the box? So you'd have to flip back a couple pages. It's talking about, it looks like some sort of crackers or Chex Mix or something. So let's see. So they ended up having a formula that represented the volume of a box, and when they answered the question, They got 2 answers. Well, 3 technically. 0 would be a possible side value of the or volume of the box, and then there's a positive and a negative. We didn't choose a negative one because negative volume doesn't make sense in our universe, right? Since volume is the product of distances or lengths, and lengths are positive by definition, right? So that's why. So some explanation to, actually let me flip that. Yeah, negative dimensions have no meaning, right? Some explanation to that effect would be fine. Let's see. Just to work on our conceptual understanding of things, I'm going to do number 3 real quick. Man, after today, we will have survived our first week after vacation. Getting back into the swing of things. Good stuff. Let's see. 1, 2, 3, 4. There's my 4 sad coordinate planes. Let's see. An even degree polynomial with 1 relative maximum and 2 relative minimum. All right. So let's throw these down. So 1 max, 2 min. And if it's even, its end behavior has to be in the same direction, right? So it looks like a W would fulfill that, right? Something like so. Would do that. Odd degree polynomial with 1 relative maximum. And let's see, and 1 relative minimum. Leading coefficient is negative. So let's see, so it's got okay, I did happen to do this in the right order. So if it's negative leading coefficient, it's coming down, and then up, and then down. All right, so, yeah?
We did it like that, but like the arrow is this way on the right-hand side, but yeah, it was like it's going
Meaning like this?
instead of going like this, it's going like this.
Well, this would have had the last fact is what made me choose this one over this one. This one would have a positive leading coefficient, so this would be like a positive x cubed function. So that's why I would have had to narrow it down with that last fact. But yeah, I mean, if it was like a short answer question, I'd give you obviously partial credit for the rest of the information you derived from it. Let's see, even degree polynomial function with 4 relative maxima and 3 relative minima. So 1, 2, 3, 4. And then in between those would be the minimum. 1, 2, 3. I feel like it's a very Sesame Street way of counting. I'm fine with that. Oh, let's see. Can I do this all in one? And they don't necessarily, like, the minima and maxima didn't all have to be on the same height, right? Like I could have had this one swoop way down, and this one here, and then like this one swoop way, way down, right? So I just want to point that out. Like, I'm just drawing a really, I don't know, basic understanding of what this shape looks like. Let's see. Yeah, question?
When it comes to like plotting those, you can just kind of put that
Right. Well, I mean, at this point with this limited information, we have a rough idea of what those look like, so that would be fine. But then once we get to something like where we actually have a table, let's see, actually, I don't want to broadcast this on the internet, because then the other kids could cheat. They could freeze the frame. Ooh, that would have been a classic.
Is this always recording?
Yeah, I'm recording right now,
Oh.
so I have to get my headset on. Or on the internet. But yeah, still ask questions, because then it'll be good. It'll be good. So yeah, so if I have more information, like what the equation actually was, then we could figure out the y-intercept. We could have generated a table, and then based off of that table, found some estimates for local mins and max. And then you could plot those actual points, because those are x comma y's, right? So you could plot those points, or plot where the x-intercepts are, right? And then you could have a better defined curve. Is what we'd end up getting, but so yeah, but yeah, and this is basically like what the picture in my mind would be for these. So they're not super accurate, but it just gives me a general idea of what I'm going towards. Let's see, odd degree polynomial with 3 relative maxima, 3 relative minima, and the leftmost points are negative. So the leftmost points are negative, so it's like that. If it's odd degree, I know it's pointing in opposite directions. So what would the leading coefficient of a function that has this end behavior look like?
Positive.
Right, that's a positive leading coefficient, right? Because the negative y and the negative x is matched up, and the positive y and the positive x is matched up. All right? So the cactus is like that. Right hand down is what I'd like that. I don't know. At some point, I'll just have to turn on the webcam and actually do all my little hand gestures and dances in front of it. But not today. Not today. So I do know that. So the leftmost points are negative. So that means if this is coming up, the first max, it's going to hit at maximum first, and then it's minimum, right? So my minimum couldn't have been to the left of the first maximum is my only point there. But I mean, I would have graphed this with some trial and error. I don't necessarily expect that you'd get it right exactly the first time. Like you might have started a sketch and then realized, oh, I backed myself into a corner where this last fact won't be true. And then you could kind of tweak it as you need to. Right, so there we go. So, let's see, other good questions for us?
Can we just look at question 4?
Gladly. Was that even one that we did, or?
Yeah. I think so.
No.
It wasn't?
We didn't have to, but
That's why I didn't do
we'll just give it a quick read over here. Let's see, consider a function, blah, blah, blah. Evaluate f of x for successive integers between -4 and 4 inclusive. So basically what part A is saying is make a table of values where you plugged in -4 through +4. And the way you evaluated those, you could have done direct substitution where you actually plug in -4 here and here, or we could have done synthetic substitution, which is a little bit quicker. Or, I mean, we could even, actually, ¿Dónde está mi calculadora? We could have even, if we had a graphing calculator and it was allowed on a quiz or something like that, we'd even be able to plug it in there and get those. And then it has you analyze where the zeros are. Actually, oh, yeah, we might as well do this. This will be good practice. Actually, yeah. I'm going to do number 4 for real. You don't have to write it down or not. It doesn't matter to me. But it's going to walk us through kind of the whole concept really well. So let's see. So here's our function. Could someone tell me the general shape of this function based off of the equation? Yeah, it's W because it's a 4th degree, and the leading coefficient is positive, right? What's the y-intercept on this? 10, right? Because that's the constant. How many x-intercepts could it have? 4. Up to 4 because of the exponent. And now this one's actually missing a cube term and a linear term. So as a result, it will actually have less than the 3 bends that it could. And it will likely then also not have, some of the intercepts may occur multiple times. Like it might be some duplicated ones. So this will be interesting to see. So in order to graph this, let's see. I'm going to y equals x to the 4th minus 8x squared. I'm just going to make a table real quick using the man, that exponent thing threw me off again. I'm not used to calculators that do that, I guess. I think there might be a way I could shut that off on this. X squared plus 10. So I'm graphing this using a calculator. So I plugged it in as my function. Technically, I could hit the graph button, but we'll pretend that's cheating right now. Technically, I'm cheating right now. And here's my table. Press plus for delta table. Yeah, let's change our count. We're counting by ones. All right, delta is difference, right? That's the increment between my x values, basically. What did I do wrong? What did I do wrong? 1, right? Huh. All right, well, normally I don't use that method. Oh, tables, that, classic. I started at a decimal, so adding 1 to a decimal is going to keep giving me decimals. Let's see, we wanted to start at -4, right? And count by ones. No, nope, no cheating. I hit the wrong button. All right. So here's part of our table. Let's see, and then I'll have to scroll down to. And on today's quiz, our tables will be generated for us. Let's see, and then let me scroll down. It looks like I need just a couple more points. Let's see, I guess I have to make sure these are somewhat the same size now as well. That's peculiar. And that's close enough. I don't care. So based off of this table, it's kind of sad looking, but that's okay. How do I know where an X-intercept occurs?
Oh, wait.
The negative.
Yeah, when the y values change signs. So I expect that my x-ints, it looks like I'd have one occur somewhere between -2 and -1, right? So -2 less than x less than -1, sorry. And then do you see another place where it changes sign? Oh, wait, blah, 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 blah. I missed one already. There. From 19 to -6 has an x-intercept occurring. I'm sorry.
Can't see anything.
Let's see. So it goes from -3 less than x less than -2, and then from -6 to 3, the sign changed again. So we had two x-intercepts like back to back there. You notice? So that's -2 less than x less than -1, right? And then let's see, where's another sign change? I don't know if you guys can spot it. Yeah, from 3 to -6, the sign changes. So that's 1 is less than x is less than 2. And then from -6 to 19, the sign changes. So that is 2 is less than x is less than 3. All right, so because 2 and 3, right? So those are my x-intercepts. How about some maximum or maxima? How do I know where a maximum occurs?
When it starts to increase after a decrease or something? Or like...
It like increases.
Right? A maximum occurs, it has to be increasing and then start decreasing. So there has to be a change in direction. So to go from 138 to 119, that's downhill. 19 to -6, downhill. -6 to 3, uphill. I think we just found a minimum, all right, because it went down and then up. I'm looking for up and then down. And then from 3 to 10 is up. And then from 10 to 3 is down. Aha! So somewhere in here, right, it went from 3 to 10 back down to 3. So from -1 to 1, and I need 3 points to have verify that it's changed direction. That's why I'm kind of choosing the outermost of those 3. But yeah, a local maximum must have occurred somewhere there. Now let's keep looking at the direction here. So then from 3 to -6 is still down. -6 to 19 is up. And then 19 to 138 is up. So let's see. So it looks like there's only one maximum in there. How about minimum? Yeah, right. So between these, it went from 19 to -6 back up to 3. So it looks like right there. So a minimum value occurred between -3 is less than x is less than -1. Am I right? Am I right? And where's another minimum value? Right. So it went from 3 down to 6, back up to 19. So there's a change in direction here, right? So that's a minimum. So the x values that occurred between were 1 and 3. So 1 is less than x is less than 3. So let's see. I don't even know if I started analyzing this right. Let's see. Where do the zeros appear? That's what we did there. They said to approximate the zeros to the nearest tenth. Well, typically I would actually have zoomed in the tables and plugged in some values closer. But if I was like really just estimating, all right, if there's a sign change here and it was at 19 at one point and -6 at the other, all right, it was 19 high at -3 and -6 at 2. Which do you think the x-intercept will be closer to, -3 or -2? Which was 0 closer to for the y value? Right, 0 is closer to the -6 on the y, so in terms of the x value, it's got to be closer to the -2. So it's, you know, I don't know, like 6 to 19, I'm kind of comparing it. Maybe it's like -2.2, I don't know. It's a guess, all right? So you could kind of pull some guesses like that. Right, we just recognize that it's weighted towards that one side. Actually, let me undo those big red marks I just put on it. So I'd say like -2.2-ish, right? Between -2 and -1, it goes from, let's see, it's -6 at -2 and then +3 at -1. 3 is closer to 0 than -6, so my answer must be closer to -1 than it is to -2. So I would probably call that -1.3, because I mean 3 and 6, you know, it divvies up that space a little bit differently. So that's the way I'm kind of thinking of it. Not a perfect analysis once again. Man, I keep having to get rid of my circle before I -1.3. And then between 1 and 2, 3 and 6 again, so I'd say like around 1.3. And then between these two, it's closer to the 2 than the 3. I'd guess like 2.2. I don't know. And the reason I'm choosing that is like 6 and 19 adds to like 25. And 6 out of 25 is kind of how I'm estimating this decimal. I don't even know. Yeah, so that's how I'm just kind of guesstimating that. I'm thinking of that fraction, so to speak. No, on the quiz, I'll actually have it more set up like this, where my tables are a little bit closer. Yeah, but I don't think I actually have you round to the nearest tenth, I guess. So let's see. State the range where the negative. Okay. Part C was just kind of talking about where is it negative, where is it positive. We don't necessarily need to do that so much. Relative max and mins. I think that's what part C was doing. It was just setting them up for D. We do kind of our own analysis. But let's talk about graphing this. Let's see if I can get a decent graph here. So I've got values 1, 2, 3, 4. 1, 2, 3, 4. Let's see. It looks like I go all the way up to 138, so I'm not going to fit that on my graph. I might not even fit up to 19. Maybe I'll just count by 5s. 5, 10, 15, 20 for the y-axis. 5, 10, 15, and -20. So let's start labeling our points. So our x-intercepts, somewhere between -3 and -2. So there's -3, -2, and we said it's probably around there. And then we had around -1.3, we had around +1.3, and then around +2.2. So those are our x-intercepts, somewhere in those ranges. Our maximum, somewhere between -1 and +1. So -1, +1. And about how high should I put my maximum, do you think? My local maximum occurred right here. So what y value do you think I should put for it? For the y values? So y values are in this column.
Oh.
Right? How high do you think it should go? Yeah, probably somewhere around 10. I mean, it could be higher than that, but I'm probably going to just have it kind of land right there. So there's no guarantee that that's actually the maximum. It could be like a little bit higher and to the side. I mean, like it could be, it could be kind of a little lopsided. It doesn't necessarily have to be symmetric. In this case, I think it will be, but yeah, so there's my maximum. And then how about my minimum? So I've got one right here. And how low do you think I should go for my minimum? Somewhere around -6. Sounds good, right? So I have a minimum occurring here around -6. So if this is -5, -6 is about there. And then the same here was about -6. So let's draw a picture of what this actually looks like. So I've got something like this, and like this, and then like this. And, oh, I missed that, X-intercept. All right, and if I check the old grafing calculator, that is pretty much what I got, right? So I just want to point out, like, you can kind of pull all of this information together eventually to get a graph. And I mean, and if I wanted, I could have even gone to the point of actually plotting these points exactly, right? Like I could have plotted -1, 3, 0, 10, and filled in all the rest. I ended up just plotting the x-intercepts, max, and mins, which is kind of all I'm looking for today, is that idea. But so this problem kind of covers the whole concepts from 8.3, which is why I liked it. But how about any questions on maybe some of the earlier stuff? I don't know. What did we even do earlier? Oh, yeah, we did remainder and factor theorems, right? Those ones are good. So talking about depressed polynomials. And then the first section was all just analysis of equations like odd and even, and what the end behavior was, the number of bends, right? So we just kind of spent a lot of time talking about that. But would you like me to, do something about synthetic substitution, or?
Wait, how can you tell if it's odd or even?
The degree of the exponent, all right? So the leading exponent. So because this was a 4, it's an even function. So it's based off of that. And then when the coefficient of my leading term is positive, that's when it's pointing up, negative points down. So.
On the quiz, like, will it say that you have to use synthetic division on some of them, or like can you use long division on some of them, or remainder theorem and stuff?
It doesn't. Yeah, for some of them it doesn't specify. You could use either.
Okay.
And then there is one where I actually say use synthetic substitution to find these two values, right? So that would be directly synthetic. Actually, that was somewhat confusing because direct substitution is the other form. I said directly synthetic. Made it as confusing as possible. So what do we got?
Will we have to produce our own answers for like end behavior, or is that
You should know how to do your own. I mean, even if like if you can draw these 4 graphs based off of this information, you know everything about end behavior you need to, right? So, and if it's just a matter of the language of end behavior, to describe this arrow, I would say y approaches -infinity as x approaches -infinity, right? Because y is going down as x is going to the left, right? So it's just a matter of being able to analyze it that way. But yeah, if you know these graphs, you know everything about end behavior.
Oh, should I put my homework in the folder?
Sure. Yeah, I think we're probably done then. I'm guessing. So so we'll start the quiz in just a moment.